Geometric probabilities involve comparing the areas of different figures. And so let's take a look at this dartboard and imagine if I were to throw a dart at this at random, assuming I hit the board, what's the probability that I land in one of the different regions? So on the next screen we'll take a look at our different probabilities we want to find, although we're going to base it on this target right here, so maybe I come back to this screen a couple times. So first up they asked me to find the probability of getting a bullseye. Well, in this case the areas I want to compare then are going to be the area of the bullseye, which is that green circle, so I'll need to find the area of a circle in a second, and I want to compare that to the total area. Well, in this figure the total area is the square dartboard. So those are the two areas I want to find, the area of the green circle, and divide that by the area of the square. Well, to find the area of a square, that's relatively simple to do. My total area is 18 times 18 to find the area of the square, or 324. So there's my total. In this case it's an area total we're talking about. Next up, for the green circle, I need to remember that the area of a circle is pi times the radius squared. In this case the radius is 3. So pi times 3 squared, using a calculator, I find that to be about 28.27, and then dividing this, and let's go ahead and just express our geometric probabilities as percentages, although we could do a decimal or a fraction if I really wanted to. I find the probability of getting a bullseye is approximately 8.7%. Not very high. I would expect that to be the case. It's a small area. Next up, they asked me to find the probability of getting no points. So going back and looking at my bullseye then, or my target, I can see that no points is the black section. So I want to figure out what's the probability that I land out there. In other words, I want to know if I land inside of the square but outside of the circle, so these little corner pieces. Well, you may recall from geometry that to find that, what I'm going to do is end up subtracting two areas. If I take the area of the square, which we already know, and then subtract off the area of that red circle, I should get the area of just what's left over, the little border pieces. So that's what I want to find for the top of this. The area I want is no points in this case. So I already know the area of the square from the last example. That was 324. And then I'll subtract off the area of the red circle. Again, the area of a circle is pi times the radius squared. I can see the radius of the entire circle all the way out is 3 plus 3 plus 3, or 9 for that total area, or total radius. So 324 times, or minus, pi times 9 squared gets me an area of those border pieces of about 69.53. Well, recall what we're trying to do is figure out what's the probability that I land there. So that's the area I want to land in, out of the total area of this figure, which remember is still that square dartboard shape. So my total area is still 324. Once again, dividing those and changing my answer to a percentage, I see the probability of getting no points is about 21.5%, so much higher than the probability of getting a bullseye. Last up, I want to find the probability of landing in the yellow ring. So let's one more time take a look at our target and see what this looks like. So I want to figure out this yellow spot right here. That's where I want to land. I'm thinking this time, since it's a ring shape, I'm going to use a similar process to what I did last time. Let's find the area of this entire yellow circle, but then subtract off that green circle that's inside to get rid of that area. That should be the area of what I want. So again, my thinking is going to be, let's find the area of the yellow circle and let's subtract off the area of the green circle on the inside to find the top of my fraction for my probability fraction. So the area of the green circle, or the yellow circle, is going to be 6 squared times pi. It would have a radius of 6 if you look back on there. The green circle's area is going to be 3 squared, that's its radius, times pi. And once again, using a calculator to find that area, I come up with an area for the yellow ring of about 84.82. So that's the area I want to land in. That's going to be in the top of my probability fraction. Once again, I'm going to divide this by the total, and once again, that total area is still just a square. So dividing it by the area of the black square, which was 324, I find that I have a probability of landing in the yellow ring to be about 26.2%. So if I were to close my eyes and throw a dart at random, the highest probability, at least of the ones we've found so far, I'm most likely to hit the yellow ring out of the ones we've taken a look at so far, because it has the highest probability.